Students, I am here with the solution of example 1.7 of your NCERT textbook. So here an equilateral triangle is given and at each of its vertex three charges are placed. So at vertex A charge Q is placed, at vertex B a similar charge Q is there, and at vertex C a charge minus Q is placed. Okay, so I have shown the charges separately here. So this is vertex A, q1 equals to, so I have named these charges as q1, q2, q3. So this at vertex A q1 is q, at vertex B q2 is q, and at vertex C q3 is minus q. So there is only one negative charge, and that is at the vertex C, whereas the charges at vertex A and B are positive. Okay, so if we see the diagram properly, we can see that all the three charges are of same magnitude, and the magnitude of each of the three is q. Okay, and each of the two charges are at the same separation. If we talk about the charge q1 and q3, they are at a distance L. If we talk about the charge q1, q2, they are also at a distance L. And if we talk about the charge q2 and q3, they are also at a distance L from each other. So for all three of them, we can say that their magnitude is same. So I have written that the mod q1 equals to mod q2 equals to mod q3 is q. That means their magnitude is same, and r is L. That means the distance between each of them is L. Okay, so let's first try to, so what does we conclude from here? We can conclude that the force exerted by each of the charge on the other charge is same in magnitude. If we talk about the force on this charge q3 due to q1 and q2, they will be same in magnitude, because for each pair the distance is same and each pair has same charge. So let's try to find out this force between any two of the charges. So let's say the force is F. So we know that the formula of the force F equals to K q1 q2 by r square. Now put the magnitude of q1 q2, so q into q, and r is L. So we get the force equals to kq square by L square. So this is the magnitude of the force which is acting between any two of them. Okay, now so this is the force. Now let's try to find out the net force which is acting on charge q1. So let's do the calculation of the force on charge q1. So in order to find the force on charge q1, I have shown the forces which are acting on this charge q1. So if you see, there are two charges around q1. One is q3 and other is q2. Okay, q3 is negative, q2 is positive, and q1 is positive. So this green vector is the force which is exerted by q2 on q1. Now if you see, it is repulsive in nature. Why? Because q2 and q1 both are positive, hence q2 tries to repel q1, hence the force is repulsive in nature. Whereas q3 is negative in nature, hence it tries to attract q1 towards it. Hence this yellow vector, which is the force exerted by q3 on q1, will be towards q3, because it tries to pull q1 towards it. Okay, and I have shown the magnitude by F. Now if we see the diagram, the angle between these two vectors will be 120 degree, because we know that this is an equilateral triangle and the angle between any of the two sides is 60 degree. Hence if this angle is 60 degree, this angle will become 120 degree. So we can see that there are two forces which are acting on q1, each of same magnitude F, and the angle between them is 120. So let's find out the net force. which is acting on Q1. Okay, so in order to find the net force, I have separately shown those two forces. So this is the green force which is exerted by Q2, and this is the yellow force vector which is exerted by Q3, and the angle is 120 degree. No, so we know the formula of finding the resultant of two vectors. So if two vectors are given and the angle between them is given, then we can easily find out the formula. We can easily find out their resultant by using the formula this. So the F net, which is the force acting on the Q1 charge, so I have shown it with F1. So this is the net force which is acting on Q1. So this will be under root F square plus F square to F into F cos 120. Cos 120 because the angle between both the vectors is 120 degree. So if we solve this out, we will get that the resultant is F. This we have also studied in class 11. This is very important result. So if there are two vectors and both are of same magnitude, and if the angle between them is 120 degree, then their resultant is same in the magnitude to each of them. This is an important result. You should remember this. It will save your time. Now, so we get that the resultant is F. And now what is the F? We have calculated it earlier. Yes, it is KQ square by L square. Okay. So now we have find out the net force which is acting on this charge Q1. Okay, let's talk about the other charges. So here, so the calculation of the force on charge Q2. So if we see charge Q2, it is similar to the charge Q1. See, this gray vector, this is the force exerted by Q1 on Q2. This is Q1, okay, and this is Q3. So this gray vector is the force exerted by Q1. Since Q1 is positive, Q2 is also positive, hence the force is repulsive. Similarly, Q3 charge, that is minus Q, attracts Q2 towards it, hence the force is attractive in nature. Okay, again the case is same as that of Q1. The angle between both of them will be 120 degree. So the whole calculation for the Q2 will be same as that of the Q1. Okay, so you can do it by yourself. Now coming to the third charge, that is Q3. So in order to find the net force on this charge Q3, I have shown the forces which are acting on Q3. So if you see, Q3 is negative, whereas the Q1 and Q2 are both positive. So Q1 and Q2 both will attract Q3 towards them, because we know that unlike charges attracts each other. So this gray vector, which is the force due to Q1 on Q3, will be towards Q1, because Q1 will try to pull Q3 towards it. Similarly, Q2 will also try to pull Q3 towards it, and this green vector will be towards Q2. Now, so we can see that there are two forces which are acting on Q3, and from the geometry of the triangle we know that the angle between these two vectors is going to be 60 degree. Okay, so this angle is going to be 60 degree. It is simple geometry. Now, so in order to find the resultant, so this angle is 60 degree. Okay, so we can use the same formula under root F square plus 2ff into cos 60, because 60 is the angle between two vectors here. So if we solve this out, we will get that the resultant will come out to be root 3f. So this F3, I am saying this F net as F3 because this is the net force which is acting on the third charge Q3. Okay, so it comes out to be root 3f. Put the value of F here which we obtained earlier, that is KQ square by L square. So this is the final answer, which is the force acting on this third charge Q3. So we have find out the force, net force which is acting on Q1, we have find out the net force which is acting on Q2, and we have find out the net force which is acting on Q3. Thank you.